Hello there, welcome to Architect Interview Question Series by Knowledge Powerhouse. Let's go on to our next question in this series. Question is, how does circuit breaker pattern work in a software system? So circuit breaker system, this is a pattern that has been in use in the physical world, and now we have to see how we use it in software world. So if you see this diagram, this is a simple example. Like we have a normally battery, we have a light bulb, and we have a switch. And that switch is the one which is a circuit breaker. It's the simplest way in your house, everywhere, like in your office, you see switches. They are like similar to the circuit breakers. And then they have complicated circuit breakers which are in your main panel of your electricity dashboard. Now in software, what we do is that sometimes we have failures in the system, and those failures may take variable amount of time to recover from. So now in such a situation, we use a circuit breaker pattern. Like in physical world, if somebody electrician is coming to fix something, some failure, they first switch off. So that is what they have broken the circuit, and then they start operating on it. So same thing is in the software world also, and let's see how we use it and what are the benefits of it. So first thing is that this pattern can help in improving the stability and resiliency of an application, and we will understand how it can do it. Let's say we have a distributed environment, and in a distributed environment, it is expected that certain calls or requests will fail because we have remote resources and we have like different kind of clusters. So there are services that can fail with some transient errors, like there is a slow network connection, or there is heavy load on the system, or there is a timeout, or the resource itself is being overloaded, like server is totally overloaded. In that scenario, some of the calls will fail. Now, what happens is that this kind of failure can typically correct by themselves after a short period of time. So in some time, if you this like network bandwidth will be high and you can resolve. Traffic may reduce. So those kind of things can take place by themselves. So therefore, what we do is that we implement a retry pattern so that we can make our cloud robust. This application can be robust, and it can handle such kind of transient failures, right? So using retry, after a few seconds, you can try and then it will be successful. But there are times when these failures can be for longer duration, and they can be due to some unanticipated events like which are not expected. And because of that, it may be like that we take a variable amount of time to fix. It may be a minute, 2 minutes. In such a case, the retry may not be the right way, right? So what happens is that in such a case, we can get some kind of a partial loss of connectivity for like some time, or there can be complete failure of a service. So these things can cause a longer duration failures. So in that case, retry may not be good, because if we keep retrying the operation and that operation is not likely to succeed, we are actually increasing the load, right? So we are like sending multiple retries, like one request is becoming 10 retries, right? So we are 10 times increasing the load unnecessarily. So in such a case, the application should quickly accept that the operation has failed and try to handle the failure in a different way, right? So that is what the strategy we have to follow. Or if you see this example, sometimes in Windows or some operating systems, we see so many these kind of dialog boxes where if your service is not working, and still we still getting these kind of dialog boxes because of the retry. So if service is overloaded in one part of the system, it may lead to cascading failures in the other part of the system, and we can keep getting multiple messages, so it increases its load, right? Let's say if there is an operation that is invoking a service, and we are implementing a timeout after a specific waiting time. So understand by example. So after some time we do a timeout. Let's say after the 30 milliseconds we do a timeout. Now the timeout means that it will reply with a failure message if the service fails to respond within this period. Now, due to this strategy, many concurrent requests will be blocked until the timeout period expires. And these blocked requests may hold on to some critical resources like memory, threads, database connections, and this would lead to the scarcity of resources. Now, whenever this kind of situation arises, then it's like not preferable to hold on to those resources. Rather, we should abort the operation immediately so that the resources can be uh, released, right? So, and the operation should be attempted only when the system service is up and the operation have a high probability of success, right? So, like if this if your server is already loaded and you try to do retries, you try to do a timeout, it may make the situation worse. So, some set of operations have to fail at that time. Now, how do we do that? For that, we use circuit breaker pattern. What we do is that circuit breaker pattern will prevent the application from repeatedly trying to execute the operation. I mean, if the operation has a high probability of failure, using circuit breaker, we can automatically abort the operation. And if we allow to continue this operation without waiting for the underlying failure to fix, it will waste our precious CPU cycles, resources. That way, it will be making the situation worse. So we can use circuit breaker in such a scenario to prevent unexpected or uh, unexpected effect on our CPU cycles and resources due to these kind of failures. So we can also implement circuit breaker in such a way that application can detect when the fault has been resolved or not, right? So first case is that application detects that there is some issue, so circuit breaker comes into the action and breaks that circuit and the request start failing. And second case is that circuit breaker can come to know that, oh, application has already fixed it, it is up and running, then we can switch on again. So if the fault has been fixed, the application can try to invoke the operation. So these are like advanced way of implementing circuit breaker. Alright, that's all on this topic, and if you have further questions or comments, do post in our comments. And thank you for listening, and subscribe to our channel so that you can keep getting updates and new videos so that you have more knowledge. Thank you.